केमा म्याथ
Thank you. Thank you, Vinny. Namaste. धेरै भयो आउनु त हेर्नु आउनु धेरै दिनपछि तपाईँले मलाई सम्झाइदिनु भयो गुड मर्निङ के भयो
We're Hydro Rocket and we're going to launch it today for the first time in LMB. And we named it according to our names. And this rocket is generally best in the Newton's third law of motion. That is, if you have reaction, there is equal and opposite reaction. And for now, we'd like to start our work.
Thank you.
Congratulations. As an action, due to air pressure, the lead was pulled downward, and as reaction, due to pressure, rocket was
Why do we have water?
We're using it as a fuel over there to exert the pressure so that the rocket will fly upward.
Actually, when pressure is more in this rocket, the water will be falling down. That it is the action of this. So if water falls down in the rocket,
If there is no water, what won't
It will fly. The air also exerts pressure.
but up to certain height only. Infrared, meter and
We are doing since we haven't got required amount. And this is IC 7805, and this is also called IC timer, that is 555, and this is a ball. So when we doing this into that, the current coming from here, which is AC current, alternative current, is changed into direct current. So when direct current comes here, comes here, then it is passed to here, and as we have mentioned required number of voltage here, it is passed to here first. Then after another voltage is passed to here, that is in 7805 AC, 7805 IC. And this is constant IC, and if any amount of, even if 10 or 15 amount of voltage will come from here, it will make, as it is constant, it will make 5 volt. Then it is passed to this, that is IC, any 555 IC. Then it will change the voltage into frequency. That means certain amount of frequency is coming from here. So as T-Shaft receives 38 kilohertz of frequency, we should have to change certain amount of frequency into 38. So we have joined capacitor, resistor, and variable resistor. And we have mentioned the value of variable resistor as 1.85 and capacitance of 0.85 and resistance of 100 ohm. So from this, the 38 kilohertz of inner frequency is coming out, and it receives the frequency. When it receives the frequency, then it gives low output, so that bulb could not be on. But when the frequency is blocked, then bulb will be on. Let's see. We have joined there, and now. Likewise, I said that when I will block that frequency, the bulb will be on. Now let's see, the bulb is on. But when we take out, the bulb is off.
So the light is coming.
Yes, sir. The infrared wave is coming from there, and when we block this, it gives high output, and bulb will be on.
Which grade are you?
10.
It is a part of the course or
No.
no? is your extra, no? You explain so many things, yeah? How much of them are in your course?
Very less.
Very less. Okay, good. How this instrument could be used? For
For
what purpose?
remote control election, we
Can
didn't
use
use
in TV that.
as we didn't find the amount of register we have needed, no, and we are planning to make remote control bulb, but we did not due to we didn't got amount of ohm we need.
Okay. So this also could be useful for security, right?
Yes.
If somebody
If
parks,
somebody
the
pass, then
light will be on. Oh, this is very useful.
And once more,
Oh.
कति वर्ष सिगरेट ला कति वर्ष सिगरेट ला यसैले गजब लाग्यो हरेक साल आउँछु नि उहाँले मलाई हरेक साल डाक्नुहुन्छ
कति दिन पुरो होला यहाँ?
यस्तै वर्षपछि
Is this your part of your course? Are you which class?
Good morning, sir. The Power Science and Maths exhibition. Today we are here for experiment calcium hydroxide and prepared ammonia gas through this tube which is inside this bottle. So now to prepare ammonia fountain we need as the water consisting of 3 drops of phenolphthalein. So here another tube is here through which we will be passing the water. So this water then slowly passes through the tube up in the upward side due to the presence of ammonia, because ammonia attracts the water in its upward direction. So slowly the water will go up and form a fountain. First we have to form the ammonia gas.
Inside.
Yes.
So there is no ammonia gas at the moment.
No, it is clear. So here you can see the water is slowly moving upward. So that means that ammonia
Why water is going up?
due to the presence of ammonia, the ammonia attracts the water because it is more violent
What do you
in
mean by
nature.
attack?
It pulls the water in upward direction because it consists of phenolphthalein.
Phenolphthalein.
So you can see the water is rising up. It will take some time to form a fountain.
Bubbles are coming.
अनि यसलाई चाहिँ अगाडि सार्नु त्यसैले माथि
यसको सपोर्टको लागि यसमा छ
हेर भने पनि हेरिहाल्छु
Sand or soil. And you heavy and high. Stable. यहाँसम्म राख्यो भने यो अनि रिमोट We'll come back when you are ready. Is that okay? But have you seen that one in the same instrument?
Yes, sir.
The water will come.
From that tube. So from the first one.
First, this is our medicine paper. It's already blue, but
What is this?
medicine paper. We have used methyl blue, sodium hydroxide, and it's already blue. We have to wait some time for the quantity to turn into this, turn into white.
White.
Yes,
Milky.
no, not milk, just pure minerals.
I mean clear. It will be clear water.
First, we have used methyl blue, which works as inhibitor of oxygen reduction. While we turn this upside down, then oxygen it mixes with oxygen, and this methyl blue
Oxygen from where?
this one. This here.
Is it feed of oxygen?
Yes, not oxygen. We have used only air. Just it uses oxygen from there. Then it turns to blue. Then when you turn it upside sorry, it turns when you turn upside down, then oxygen turns it into blue color. methyl becomes the blue color. After sometimes when it turns white, then then there is the glucose works as glucose reacts not reacts. Glucose turns into white color, which reduces
Or is it happening?
it's already blue. I have turned it red.
You also said a smoke bomb.
Oh yes,
Very different.
these are smoke bombs.
Different.
Yes, sir. We have two examples. We have used potassium nitrate and soda, baking soda and sugar. Those three ingredients. While we burn it, there is oxidation. Oxygen is removed from here, and it emits smoke and gives out a very bright fume.
Right.
White fume and very bright light.
And sound? It doesn't rust.
Only
This so is just a smoke bomb.
yes, sir.
Which class are you? Ten.
And in place of this tube and gasser, we have used this saline bottle. As well as in place of cork, we have used this saline bottle cover. And this is delivered to, which is fixed at the saline bottle cover. And from this, gas will goes upward. And do you know, sir, why this saline bottle is inverted in downward? This is because ammonia gas is lighter in here and it directly goes upward.
Displaced? Displaced what?
It displaces water because it is
I am completing your explanation. So the ammonia will go up and it will displace fill up the gap. This will displace what?
fill up the gap and
No.
it displaces the air. And
This is also saline bottle. You are heating it, yeah? You are heating it.
we have ammonium chloride
Have
and
you tried it before?
yes, right before and it is ammonium hydroxide and calcium hydroxide. We are mixture of that and we are making
Testing.
litmus paper and drums.
It is not dangerous, huh? Now I will ask you one question, yeah? Have you seen the beaker? Beaker, is it thinner than this?
Yes, that is
Why it is thin?
because if the bottle is thick, then it there is more chances to
Okay.
break due to it.
Why it break?
Because glass, because the glass is bad for the glass. That glass can resist more heat.
Now this is thicker than beaker, yeah? Bigger or pass on the other flag.
Bottom part is
Beaker is
thicker
dangerous.
than bottom part is thicker than baker, but this middle part is thin like
This part will expand because this is not heated, yeah? When this part heated, then it will expand. So if it expands, then what will happen? It will break the glass above. So you have to heat very uniformly, then it won't break. Yeah? Yeah. So you need to, for heating, you need a very thin glass. And if it is heated, if you put a water, it will break, yeah? Cold water. Why?
With the reaction of metal, zinc we have got, and hydrochloric acid. When hydrochloric acid and both are layer, and hydrogen gas, while passing through it, it is passing in the solution of soap and water. And the hydrogen gas is being collected in these tiny bubbles. Now,
for making the hole in this glass, as we have used it as a wood bottle, it can be also replaced as wood bottle if we don't have wood bottle. To make the glass soft, we use the naphthalene ball and the sulfur and oil to make it soft, and we by the mixture of this carpentine oil and lithium bulb, we can make the hard, soft, and make the hole on the glass. So it can be used as the O's bottles also.
So now you can see there are bubbles. We have added some bleaching so that the bubbles will be a bit stronger than before, and it might take a bit larger size. And now when we sew Sir, I guess the air, it is already filled with air, sir. So that hydrogen gas is pushing air, and now there are forming air bubbles. When all air will come out, then only hydrogen gas will come there to make up sound.
So you have made a hole in this glass?
Yes, sir. Yeah, we have made.
How did you do that?
So you use the mixture of carpentine oil and naphthalene bulb. So
In the glass?
no, sir. In this bulb we have mixed this.
So turpentine oil and naphthalene ball, or you can use camphor instead of naphthalene ball. When we mix
No,
them,
no, for making a hole in the glass.
We can use the hard iron like this, and we have to
Mix it like that.
mix it like that, and we have to take the glass and just roll it round for 5-6 times. Then the glass automatically will become soft, and there will be hole on the glass.
Oh, that is very clever.
thank you, sir. Thank you.
Does it go
Sir,
up?
it should go up, but we don't. It is now air there. There is only air now, so it is steam.
When the
there.
hydrogen will start
Hydrogen,
to
it will come up.
Yeah, it is not coming yet.
No, sir. The air
There
inside
is
the bottle is now
just coming. As there is no hole, the air inside the bottle is coming out. The hydrogen gas.
Welcome to our school's annual program. This is my name is Saurabh. We are going to show the experiment on the reaction of glycerin with potassium permanganate, and our materials are potassium permanganate, KMnO3, glycerin, and paper.
First we have to put potassium permanganate in paper. Then we have to put little amount of glycerin because potassium is little slow, so we have to put little amount of glycerin. Okay. Then it will react slowly because the glycerin and potassium reacts very much slowly, so the bubble will start to come after the few seconds. So white smoke, this is burning because white smoke also came there and the copper flame will burn. So they react with each other. Addition of glycerin in a pile of paper creates several products such as carbon dioxide, water, manganese oxide, and potassium carbonate. It is an exothermic reaction, so we can like this product.
So, what would be the purpose of this experiment?
It helps to make bonfire. It helps to make the fire. So.
You can also use in winter time when there is no light.
Do you know why they react?
Because in glycerin also and potassium also the heat is present, so it reacts with each other because of heat.
That's part of the study.
That's part of the story.
This experiment in the book?
No, not.
Okay. Good try. There you go.
It is green fire. It is because the boric acid gives the green color and the boric acid.
What is gas? Why color flame is color green?
Because the boric acid, and the boric acid. Because boric acid always has to give us the green color. It helps to give the fire. And 9A.
And myself, Pravesh Maharan from 9A.
And this is galvanometer. This is the turbine. And when we pour water here,
First, this water is in the potential energy form, and we put this water in this turbine. Due to the friction, this water will turn into the kinetic energy form. And after this water went to air, this water will be changed into the electric energy, and from which
The light will
the
be produced. And
The water changes.
water
water will be in electrical energy form, and then
it passes the electricity
and
to
then
that wire, and that wire goes to straightly our
to
that
the coil of the galvanometer that we have attached here. And when we do like this to the from this we can yes, light energy. Instead of galvanometer, we can use the bulb also, but we have used galvanometer so that it will be easy to make this move around. And this is just a sample of how to produce hydroelectricity from the big dams of our country. And from this we can generate much more electricity, and then we don't have to buy electricity from other country, as Nepal is the second richest country in the water resources.
Can you explain me one thing? Why it is called hydroelectricity?
Because from the water it is produced. Here just
From the water.
in this rod we should attach the horseshoe magnet, and when we pour water here, the turbine and the rod itself will move around,
And
and
in
the
that-
magnet will also move like this.
Yeah.
Then when we put this coil, place this coil by the help of stand, then the magnet will move like this, and it will show the and it will attract this coil, and it will move around here.
Yeah, if magnet doesn't move, but it is moved, yeah?
Yeah. No, magnet is moved like this.
No, if the magnet is not moved, only that this is moved. Will there be electricity?
Yes, sir.
Yes?
Yes.
Yeah, you cannot say light. You can say electricity. No, don't say light, yeah? And what is the... you have quite explained hydroelectricity. No, you just explain.
Then when we pour this water here in this filter, the turbine will move, and this magnet is very big in size, so we need very
This is changing in color. Okay. Very interesting. Looks
It's
like.
an expression of food.
Please introduce yourself first. What name? Okay.
It's an expression of color.
What?
Expression.
Explosion.
Expression of color. Many unusual things happen while we mix milk, food color, and this soap together. And we are going to add this so the milk color. We need this milk, this food color, and this is soap and cotton swab. First, we pour some milk in the original plate to completely cover the bottom of the plate. Then we add this 4 colors, drop of 4 colors.
Sorry.
Then we have clean cotton straps, and we just dip it into the color and nothing happens. But again, if we just dip it into the dish soap, liquid dish, and just dip into the milk,
Dish soap.
dish soap, and just press in the milk, then some explosion of the milk happens. This must be just dipped in about 10 to 15 minutes.
But what does it tell?
It tells milk and fats and vitamins, fats. And this experiment
Why you do that? Which grade are you? Grade 9 also. You also? What is your name? Okay.
Today we are going to prepare the hydrogen gas with our alternative method. You know that in lab the hydrogen gas is prepared by they use special funnel, use bottle, but we are making the hydrogen gas without the help of the wood bottle. And for this preparation of hydrogen gas, we can take a bottle and take a juice pipe and take a lid pack, and this juice is from the real. We can make no, and we can take this from that bottle like this no, and this is take out from the switch. And when we put here dilute HCl, then the zinc reaction will take place.
And when the reaction takes place, then the hydrogen prepared will go from this pipe and be there, and the bubbles will start coming like that, and the downward displacement will take place, and hydrogen will collect in the jar.
Yes.
We can also make this hydrogen gas by putting here soap water, no, and bubbles will come, and we can introduce it magic. That is also one process, no. But they have done so, we do by another method, no. And if we want to check that, no, if the gas is hydrogen or not, we should have to first fill this whole jar with hydrogen gas, and after filling the whole jar with hydrogen gas, we will take out it and put a candle inside this jar. The candle will burn up, but the gas inside this jar whole will burn with a blue flame.
Have you done that? Have you done that?
Yes.
Good. That's best.
So today we are here with the experiment of raw egg.
Could you introduce yourself first?
It's me, Vivechana Rengmi from the egg or boiled egg. Can you identify which one is raw and which one is boiled? By just seeing.
I know a little bit. Is that something that's turning it?
Yes.
Yeah?
It is.
But you have to identify by just seeing.
Shall I try? Shall I try?
No, you can't touch it.
Oh,
but you
just
can-
seeing.
Yes.
Oh, it is hard, huh? No, I think this is boiled probably.
Okay, so we will do with the experiment.
Yeah, okay.
For this experiment, we need 2 eggs, one boiled egg, one raw egg. Then we have to spin both eggs. And then we have to just stop it by our fingertip and then realize after some time. The egg which is spin for more time is called raw egg. And the,
Show me this. Now?
then when we touch also it will
It is
spin.
still spinning, yeah?
Spin.
Okay,
But
then
when we
let's see
just
that
do
one.
this one and stop, but when we just and and stop, it will stop for it will completely stop and bubbles and go all down. And but the reason why the raw egg still spinning is that the raw egg is full of fluid. So when it is spun, the liquid. So when it is spun, the liquid. So when it is spun, the liquid will also move. The liquid will also start moving, and when it is suddenly stop it, the middle part, then the part which is next to the cell becomes stationary, but the middle part of the cell will still keep on moving. So the egg will spin and spin, but the boiled egg is solid, so they will not be. It will not move.
And then strength, and we have speed. And after that, this is the substitution of the delivery tool. And this is the cancer, this is the substitution. So firstly, we have heated the chemical of ammonium chloride and sodium nitrite. And after the heating, then before here was full of a bottle of water, but after the heating, the water slowly go displaced down, and the nitrogen gas has been collected in this gas jar. So now here is nitrogen gas has been collected. So to test the nitrogen gas, we have to burn this magnesium ribbon and insert in this gas jar. And after that, the yellowish white powder will be formed.
It smells like ammonia.
That shows the presence of nitrogen.
Actually, we are making this, so it is economically very cheap. In school, every student cannot test the experiment by themselves, so they can try it at home. So only the chemicals required. So
So we have tried to make it less cheaper, economically accessible.
Do you have lab in Mexico?
Yes.
Everybody does that.
We have exhibited this because we can tell the people that we can also learn science in our home.
Yeah.
By because I think.
Have you tried that experiment?
No, sir.
No.
And I think we have got common cold. Did you recognize us? No. Yeah, okay.
You can
Yes.
smell it?
Yeah, you can smell it and guess. Okay, this is apple.
Yeah.
Yes, first of all, will you do experiment or we can expand directly?
What?
Do you want to do experiment or we can
So you can experiment.
experiment? Then we have to close.
Okay.
We have to. Excuse me, sir, can you?
Yeah, I will be honest. Yeah, okay.
I will smell. This will have. You can eat it.
Oh,
You can eat it.
eat
Now.
it.
Which?
And the smell is apple.
So I think.
This is different.
No, it is same.
No,
It's same.
the smell is apple,
But I
but
think
the taste is
apple. The taste is also apple.
I don't think so.
I think so.
This is like a carrot or something, yeah?
Now.
Now what happened?
Now you can open it. Yes.
Yeah, can I?
Yes.
If it's spotted, I'll see the difference.
Same way, and this figure also reduction, the same reduction.
If it is reduced by from this
Point, then we can see that perfect rectangle is formed, and we know that volume of rectangle is equals to length into breadth into height. So this one is the length, this is the breadth, and this is the height of the rectangle.
So as in the cylinder, it is the breadth of this rectangle and it was the height of the cylinder before, and likewise it
We can see here also enlargement and reduction.
In camera, there is with the help of that zoom camera.
Zoom. That is
enlargement, and sometimes
and the same photo can be enlarged from the same size to bigger. And this bigger photo can be reduced in same size and smaller. No? So reduction this is and this opposite is enlargement. Yes, reduced. Good morning, sir. Welcome to our math exhibition. Today we are.
यो नंबर ये छोड़ दो ये टेबल में देखाओ सक्छ ए स्क्वायर माइनस बी स्क्वायर यहाँ देखाउनु पर्छ यो टेबललाई चाहिँ यो टेबलमा चाहिँ टुक्रा गरेर देखाउन सकिन्छ सक्छ चिन्जानु मध्ये कसैले यसै टुक्रा गरेर सक्छ सक्दैन सक्छ सक्दैन सक्छ किन नसके किन सके स्क्वायर चाहिँ बनाउन सकिन्न यसलाई स्क्वायर बनाउन सक्दैन स्क्वायर बनाउन के गर्नु पर्यो यसलाई अहिले नै काटो भनेको थाहा छैन भने थाहा छैन भने ऊ सरले बताइदिन्छ म बताइदिउँला तपाईँहरूलाई मद्दत गर्छु सक्दैन कुरा गर्छु आफै कुरा कसरी काम
चाहिने भने यतिसम्म छ
त्यो पनि कलम छ कि छैन उनीहरूकै कलम युज गर्न जाउँ न यो अर्काको चाहिँ बडो ल
जस्तो सर नि कन्ट्री छ सर
ल हरिबार कसरी चाहिँ त्यसो यहाँ नआउने आफ्नै टेबललाई स्क्वायर कसरी बनाउने
यसको आगे सेप ठ्याक्राको बराबर छ यसको होइन ठ्याक्क फिक्स सेप छ भने हजुर
90 डिग्री मैले बनाउनु पर्दैन तिमीले बनाउनु पर्दैन कसैले बनाउनु पर्दैन अलरेडी 90 डिग्री
Like in the road, and if we won't follow them, it can be dangerous.
At the moment there is no light. I'm driving here. Yeah, I'm driving. Shall I go?
When the light is not on, you make
So I stop here.
Yes. When the red light is on, then
Well, I know that. I am a driver. I'm coming here, yeah? The red light, so I stop. Now?
and now when after some while when the yellow light gone, then the car needs.
Now what else shall I do?
Now you should drive slowly. Slowly you may
Stop now.
yes, slowly and after a while when the green light gone, then you may go.
यसले के राइट साइड
राइट भन्ने चाहिँ यता थियो हैन
यो हातले यसले साउन्ड गर्छ यसले चाहिँ यसले राइट भयो 160 होला त 140 होला बढ्छ नि अनि सानो छ नि त फेरि रक जान्छ अब यहाँनिर जहाँनिर हर्टबिट सुरु हुन्छ त्यो पोइन्ट सुन्नु अनि जहाँनिर एन्ड हुन्छ त्यो पोइन्ट सुन्नु
Water is the conductor of heat.
Oh, good.
First of all, I'm Pradeep from 17 and I'm Slow Pokhel from 17. I like to request my
First of all, explain me what is conductor. You said bad conductor. What is conductor? Poor conductor, bad conductor. Yeah, what is
the materials which not to pass electricity. For conductor heat, the materials which doesn't pass heat easily is called heat conduction. The process of transmission of heat due to random kinetic particles of the medium over the position is called conduction and convection.
not bad?
Same
word.
I'd like to request my friends to say something about apparatus required in our experiment. The apparatus required in our experiment are test tube holder, beaker, spirit lamp, matchstick. We use this beaker because this is the worst material, so we can reuse it. We have original beaker also. This also. First, and if first we should go on the spirit lamp, and we should heat the test tube with test tube holder for about 1 minute.
What will come out?
But in lower part it is full and upper part is void.
Already void. So what does it tell?
It tells that water conducts but doesn't water convects but doesn't.
Yeah. Then
For this experiment, we have first tied the glass rod in the stand so it will not fall down. And at first we use the hot water so it will be fast. Then we put the water in the
Then we put the cork should be airtight.
And then? Oh.
Should be airtight. Then we use matchstick. Bond display lamp.
On its break. Have you done this practice?
Instead,
How
this
many
cork
times?
plier 2 times.
2 times. Okay.
Go a little bit fast, so otherwise water will
So it will break, huh? No.
only water will come. Cork will also come.
Explain me why it happens.
When the heat is supplied at the bottom, the pressure inside the test tube will increase and it pushes the cork.
It's coming this way, huh?
What is, I think, is not rated.
Now it won't come. It is it's already giving some. Yeah. But it's okay. I understood.
Today the matches we need that paper, candles, milk, candle and matchstick. First of all we have to write something. Can you write it? Can you?
Okay, that's all.
Okay. But then we'll burn
Then
the
we
candle.
should have to burn the candle. Then we should have to put the paper above the candle, burning candle. But let's see what's happening. Here is your name is going to begin to.
You can see the
You are cooking, huh? Cooking letters. Milk. So what is the purpose of this experiment?
the purpose of this experiment, we can send a secret message to others by
Papa? Send a message. Message.
And,
So you have to take a wet message.
yeah, those who understand this meaning by how can we do, those who understand they can do this, but those who understand they cannot do it.
But you have to send the message wet.
Yes.
Get wet, huh?
Yeah. When we can see clearly also. When you get wet, we can.
It bends.
It bends.
This is due to the reflection.
My question.
What's grade?
7.
7. So you studied in this school from the very beginning?
Yes.
Okay, what you are going to teach us? Huh? What is this?
Say about air pressure.
Huh? Air pressure. Okay.
Good morning, welcome to our school, and we are very happy that you visited in our school.
Okay, thank you. Thank you.
Came closer. So it is very simple and interesting experiment. Hope you can understand it well. For this experiment, 2 balloons, thread, stick, and a solution. As I told you before also, it is really very simple and interesting experiment. But there are many things hidden in this experiment. Firstly, we have tied 2 balloons on both sides of the stick with the help of thread. First of all, so you blow the air with our mouth. Then after I'll blow the air with the help of the
Okay.
You might have many questions murmuring around your mind. But don't worry, we'll try to answer all the questions. Firstly, I'll just blow the air with the help of my mouth.
Yeah.
You can see that the balloons are going anywhere.
Uh-huh.
Now she will blow the balloons with the help of her glass rod. Let's see what happens. Look, the balloons are getting closer and closer towards each other.
Really? Can I try? Oh, they're doing that.
Experiment, the air was present in this glass, and we put the glass inside this water. The glass was filled with air, and if we put it inside this water, then the water didn't go inside this glass. Thank you.
So we also know that the formula of circumference is 2 pi r. So when we multiply 2 pi r and then height, then we get 2 pi r. And that is the formula of curved surface area. So she's gonna explain curved surface
Derive the formula of curved surface area, that is 2 pi r h. Now, total surface area of any object means the whole seen part of a object, and here in this object we have seen 3 parts, 2 circles and 1 curved surface area. They have derived the formula 2 pi r h. Here we have to add the 2 sides of circle, that is 2 pi r square. So when we add these two, we get common 2 pi r, and we write r plus h.
What is the curved surface area of this? What is the curved surface area? Or the total surface area? You can I forgot to tell you your name. Which class you are from?
The title of our experiment is finding the formula for area of trapezium. First of all, we have to take one trapezium, and when we cut from middle, then we have to join this part to this side, then it will form parallelogram. But here will be on half height only, and A also and B also half only. Then we can say that area of trapezium is equals to 1/2 of A plus B into height.
Times times half height times A plus B. Some of the
As you know, this is the parallelogram, and this is the base of the parallelogram, and this is the height of the parallelogram. The multiplying base time height is equal to the area of parallelogram.
And this is rectangle. The base of the parallelogram becomes the length of the rectangle, and the height of the parallelogram becomes the breadth of the rectangle. So the area of parallelogram and rectangle are equal.
Which is added with the side B, so it makes A plus B. And similar here also, there is a side A, and it is added.